So Core Web Vitals is a universal user-centered set of metrics developed by Google to qualify apps by the quality of user experience. And Google uses this set in the Google search ranking system. And today I will tell you which exactly metrics build this set, what are the reasons of poor results for them, how you can improve it. Later I will tell you about the tools that you can use to measure and debug Core Web Vitals. And last but not least, I will tell you about more practical examples. I will show you my project in which I try to focus only on improving Core Web Vitals on existing Angular project. And before I start, because every time when I speak, I wish I could have an assistant, a person who could ask questions or reminds me about some topic. And this time, I decided to bring one. And to select a proper assistant, I had two requirements. The first one, that this person needs to be familiar for most of the users, for the audience, and the other, that it needs to be experienced. And this is my selection. And do you remember Clippy, the legendary assistant from the Microsoft? And there is a fun fact about Clippy. So some time ago, Microsoft challenged his users and posted this tweet. And they wrote that if this tweet will receive more than 20,000 of likes, then they will create Clippy emoji Microsoft 365. And as you can see, there is like almost 10 times more. So for me, it's evidence that yeah, people like him. And the second fun fact is this is a Clippy transformation from the initial version in Microsoft to the current one, to the Clippy emoji. So for me, it's like, you know, a legendary transformation from the Pikachu to Raichu, right? It looks like you're not talking about Core Web Vitals, need some help. And this is a very useful assistant, so welcome on board, Clippy. And let's get started. Let's talk about Core Web Vitals. So why do we have Core Web Vitals? So because engineers love to model everything and have under control everything. And one day, Google engineers decided to find a way how to somehow qualify apps by the quality of user experience. And at the beginning, it's quite tricky, because user experience is very relative. So for one person, the app is nice, for another, not. And Google engineers decided to find a universal factors that rather matters for the most of the users, and based on these factors, somehow measure some metrics in the browser. And they decided that the first universal metric is loading time. So actually for everyone, if the app is fast, we like to use this app. The second is interactivity, so how fast the app responds to user interactions. And the last one is visual stability, so how the layout is stable during using this app. So based on these factors, they decided to somehow measure something in the browser. And for the loading, they decided to measure a metric called largest contentful paint. And don't be confused with first contentful paint. So largest contentful paint is the time when the largest content element is visible in the viewport, while the largest, or when the first content element. And yeah, they did so many tests on different web apps in different conditions, and they decided to find like universal ranges based on which users and developers will be able to say, okay, I received this score, so it means that this is rather like average app, like other web apps. And after this so many tests, they created the 3 zones. The first one, this is a green zone, so it means that, yeah, this is a very nice score. And for the largest contentful paint, they decided to keep 2.5 seconds. So if you receive this or less, it's very good. If you receive between 2.5 and 4, it's a yellow zone, and it means that it's not bad, but could be better, could be improved. And for scores higher than 4 seconds, it's highly recommended to be improved. So for interactivity, at the beginning, they started to measure first input delay. And this is the delay after the first user interaction. For example, after first click or after first scroll. But with time, they just had in mind that maybe it's not the best metric to measure, because actually the input delay is not the full, let's say, time of the rendering process, and not only it takes, let's say, only the first interaction, but they wanted to use more general one, and this year they switched to the interaction to next paint. And interaction to next paint also has some measurements and some ranges. So the green zone is 200 milliseconds. Between 200 and 500, it's yellow zone, so it's not bad. But if you receive more than 500 milliseconds, it's rather highly recommended to be improved. And for visual stability, They couldn't measure any time because it doesn't make sense, but they started to measure the layout shift value that actually represents, let's say, the instability. And layout shift value is a unit for one single point, but cumulative layout shift, let's say, sum up all of the shifts, and in the end gives you the value. And I really like to say about percentages of instability. So, for example, if you receive less than 10% of this value is very nice. Between 10 and 25, it's not bad, but could be better. And for scores higher than 25%, is highly recommended to be improved. It looks like you haven't explained the good threshold. Need some help. And it's a nice point, because actually keep in mind that in different network conditions, on different devices for the same metrics, you can receive different scores. And so Google, in their tools, they have like 75th percentile, this is the threshold, just to ensure that they're hitting the recommended target of most of the users. And this is segmented across mobiles and networks. So if you want to measure, let's say, one app, and you have tools in the lab, then rather try to keep the same conditions, because in different conditions, you can just receive different values, the same metrics. And now I want to tell you what are the typical reasons of poor results for each of these metrics. So for largest contentful paint and for loading time, the first reason can be slow server response time. And to improve it, first of all, try to optimize your server on the backend side, maybe on database. If it's not possible, you can think about CDNs. So content delivery networks are really nice to improve, let's say, this loading time. They decrease latency, so then they decrease the physical distance between the user and the client. And another tip, it can be caching. You can use service work and just cache some content, especially if your app is static. For slow resource load time, and the main reason are typically big assets, especially assets that are, let's say, responsible for the loading of the largest content element. So first of all, try to optimize your assets, especially images. There is a lot of potential to improve the loading time only by compressing and optimizing images. But also, for example, you can apply some techniques like preloading, especially like preloading the important resources that are necessary to load this largest content element. And the next reason is render blocking JavaScript and CSS. So basically, for this point, try to optimize your code. The less code, the better, not only because it's cleaner, let's say, and easy to maintain, but especially because it's just faster. For client-side rendering, you can consider other options to render up, for example, server-side rendering. And now let's talk about interactivity. So the main causes of poor interaction and to next paint are long tasks. So just try to break down the long task into smaller tasks, smaller asynchronous tasks. Long execution time of JavaScript. So the problem with this point is that this execution process of JavaScript can block the main thread, what means that also can delay other processes like rendering, like event handling, and so on. So try to identify, let's say, these issues, and then try to defer non-critical JavaScript. And for large JavaScript bundles, try to apply techniques like code splitting or lazy loading, just to split the JavaScript bundles into smaller chunks and only, let's say, deliver to the user at the moment that he needs, not all the, let's say, big bundles at the beginning. And for large DOMs and complex CSS selectors, so when the DOMs are, let's say, more complex and also CSS selectors, it means that the browser has like bigger overload, and just it will take more time to load. So try to also optimize it. And for instability, so the first reason is there are elements without dimensions, because if we create a website, we don't, let's say, define dimensions from the beginning, then the browser doesn't know how much space should reserve for rendering elements. So tip for this, try to always define dimensions, both dimensions for these elements. Dynamically injected content, this is also involved with animations, so try to avoid it as much as possible or just optimize. And also, quite often, the fonts are related to the shifts, layout shifts. And there are two typical effects that are related, let's say, to the process of rendering the font, the custom font. So basically, in the browser, if define the custom font to use on the website, and the browser doesn't have this, the browser have different, let's say, behavior to choose how to manage loading this font. So one, it can just wait until this font, custom font will be loaded, or it can display in a fallback font that will be just a system font. And there is like CSS property that allows you to select this property by the program, by developer. And yeah, there's a recommendation to use the optional, to set font display optional, that actually allows you to load the text in the system font, and then it gives you like very small period to load the custom font. And if the browser wasn't managed to download the custom font, then it will display in a system font, and later in the background it will download the custom font and then will keep in the cache. And also there's another tip to preload the key fonts in your web app. So just by adding this to the fonts that are, let's say, prioritized, that mostly are used in your web apps. Now I want to tell you about the tools that you can use to measure and debug core vitals. So basically, we can divide them into two categories. The first category that are tools in the lab, what means that we will measure the core vitals in simulated environment. I think the most typical example is a lighthouse, that you can actually simulate the network conditions, the different devices, and so on. And then we receive the results for these metrics. But tools in the field will, let's say, work on the aggregated data, will work on real data from the users. So they're more accurate. But there are also some, I would say, more limits on this side of tools in the field. For example, you will need to have some traffic for these tools. So for the apps that are not on production yet, then you're not able to use these tools. And also, for example, sometimes you have to be the owner of the site. Or for example, like for page speed insights, you cannot see the full, let's say, data, but only the data from the last 30 days. So yeah, the tools in the lab, besides Lighthouse, there are also Chrome Dev tools, and there is the performance tab in which you can check the core vitals, but also web page test and different browser extensions. In the tools in the field, page speed insights, but also Search Console, Chrome User Experience Report, different browser extensions, and also other real user monitoring tools. And I added this because actually everyone is able to build this kind of tool, because there are open APIs that allows you to measure these particular metrics. And now I want to tell you about the biggest secret how to keep core web vitals under control. So there is a nice integration of Lighthouse with budget JSON file and GitHub Actions. So actually, by integrating this, you will run kind of tests, automatic tests, that will test your, let's say, these metrics. And this is how it works on the Lighthouse side. So actually, you need only to configure this JSON file, and you can specify the metrics that you want to track. So for example, cumulative layout shift of first contentful paint. And then actually you can configure the GitHub Actions in this way that with every, for example, pull request, you will run these tests, and then actually we'll see how during the development mode, you can track the process, let's say, how it will impact the user experience and the performance. And this is the page speed insights, how it works. As I told you, it only measures and shows you the data from the last 30 days. And also sometimes you cannot see the data for some apps if they don't have enough traffic. And the good thing about this tool is that it's very easy to use. You only need to have the access to the app, and you don't need to be, for example, the owner of the app, of the site. And actually, I think it's the easiest from this category of tools, the easiest to use. And now I want to tell you how you can build by yourself this kind of tool. So there is a Node.js library called Web Vitals that gives you just the functions that will give you the result for these metrics. And this is the example, of course, the basic one. And you can see the output and the model of the response. So you will receive, of course, the most important thing, the value, but also, for example, the entries, so the, let's say, nodes of the DOM that are responsible, let's say, for these measurements that are related to this measurement. And what you can do, to build this up, first thing, you can just keep this data in the database. You can send to the backend from frontend, measure on frontend, send to backend, and keep on the database. But another thing is that if you don't want to, for example, to use backend, you can integrate Google Analytics. So then you can track this metrics as a Google events. So you can put the value as the event value. And then without backend, without database, you can just analyze them in Google Analytics. So this is another way how you can track by yourself the core Web Vitals. And now I want to tell you about the demo app. I will show you the app that I built in the past. And I only wanted to focus on improving the core Web Vitals. And it's funny because I built this app many years ago when I was a student. And my first reaction when I saw the code was, when you see your code after a few years, sometimes it's a bit funny. And you can find some issues, at least one, and then more. But then you think, OK, maybe it's not so bad. So some refactoring, it's not so bad. But yeah, the most important thing for me was just to focus on improving performance and user experience by applying the, let's say, Google recommendations and also all the tips that are, let's say, on the internet about the core Web Vitals. So I want to show you the app. So it was built in Angular, and there were the 3 main tabs. The first tab, it was like product list, like in e-commerce website. And I could switch the results, but there were not too many. There were like 100 results. And more problematic was the second tab. It was a blog where there was like 2 very long lists. The first one included photos. And as you can see, there's like, I think, more than 5,000 of items. So they were not super, I would say, performant. Like interaction worked quite well, but actually the rendering process had some issues. When I switched to posts, there's also so many elements, but on this side there were not images. So actually there were not too many issues. And on the last tab I had like kind of YouTube player. There was a carousel with some thumbs, and when I click a thumb, then I could play this video from YouTube. So OK, I started to analyze. I was thinking what to improve. And at the beginning, I wanted to focus on, let's say, on the worst thing to find maybe something that could be really crucial for me. And yeah, I wanted just to measure these metrics in the easiest way. I didn't have it on production because it was my local app. So I had to use like the simple IndieLab tool. And I decided to use this one. It was a browser extension because it gave me the metrics that I needed, and also it showed me, let's say, the result in which zone they are. And I found that the biggest issue is with cumulative layout shift. So yeah, it means that there is something wrong with my instability. And yeah, I applied the first tip that always I can see when I read about cumulative layout shift, about dimensions of images, iframes, and videos. And yeah, here you can see that in different way you can define these dimensions, but also there is a nice CSS property that allows you to not assign both, but assign one and add, let's say, the aspect ratio property that will calculate the second dimension. And this was my first learning, and also a tip for you for example, in the future where you implement, and always add dimensions to your images, videos, and also iframes. The second thing I did, I applied lazy loading because I had so many images on this website, and I did it in a native way. So I just type loading, I set to lazy, and yeah, Clippy is asking, what is the browser support for this feature? And actually, I am very glad because you can see that right now it doesn't work on Internet Explorer, but OK, we don't care anymore, right? Opera Mini, but it's like very niche, I would say. But for most of the modern browsers, it works. And I'm very happy, because I remember when I presented this talk maybe 1 or 2 years ago, I remember that the browser support wasn't very well for this feature. But with time, I am super happy that also let's say, the browsers work to improve it. And also they make, let's say, the developers' life much easier. So right now, you can only set this loading property. And it's very, very easy without additional implementation on JavaScript. So the second tip is second learning, lazy load images and iframes. Now I want to show you the last thing that I did related to the third tab with the player. So I noticed that the rendering time, let's say, is quite slow for this tab. And I found that I did a big mistake, because I implemented the thumbs of this carousel as iframes. And actually, it doesn't make sense, because it was really, really blocking. It was very slow. So what I decided to do, I just decided to replace with normal images and only leave the main iframe that was playing the video as an iframe. And it was my next learning and next tip for you. So always try to use the lightest possible elements in your web app. And I want to show you a trick how you can save any node element in Chrome Developer Tools just from from this window. So if you will click the right mouse button, there is an option to capture no screenshot. So then any node you're able to download as an image. So I downloaded each of these items, let's say, and I use them as a PNG. I downloaded as a PNG. But then I also found that, OK, maybe the PNG is not the best format to use, because right now, actually, we have much better formats like WebP or others. So the next thing I did, I converted the PNG to WebP. I used this kind of converter because I only had a few images. But actually, if you will have much more, then you can use any, let's say, a tool that allows you to automate this process like this one. This is a Node.js tool that allows you to convert at once multiple images. And I want to show you that even visually, I was able to see the difference. So I had the same, let's say, functionality. But even if I refresh the page, you can see that the thumbs appeared immediately. And yeah, also I applied lazy loading. I set both dimensions. And yeah, I formatted this to the much, let's say, a lighter version than before. So next tip and next my learning, compress and optimize images. And next thing I did also was connected to this YouTube player. So I noticed that this carousel also can cause some shifting, because before I selected any, let's say, video, then it was everything is moving down. And I decided also to create a placeholder for this player. And what I did, I just created this kind of placeholder as an image, also very light, also compressed, so you can see that also let's say, the use and feel is much better than before. Next tip, next learning, reserve space for HTML elements by adding placeholders. And the last thing I did, it was related to fonts. So I preloaded the critical font, and also I used this font display option to optional. And also next learning and next tip. And I did measurements. I did in the same conditions. It's very important. And you can find that everything was in green zone. But I want to, this is a perfect moment for photos. Photo, because there's everything on the one slide. But I want to tell that, OK, I improved my, let's say, the values and core web vitals. But I think the most important for me that these tips works. And so basically, even me, from the user side, I was able to see that, OK, I improved. I could see the performance improvements. Also that the layout was more stable. And I want to tell you that I think from developer side, it's good to know which exactly changes can help you to improve these aspects. Not think only about numbers, because numbers can change in the future, because engineers are still working on these APIs. So I would say that, yeah, it's nice to find direction in which you should improve, let's say, your development, than only count the numbers. And that's all from my side. I hope you learned at least something new, at least one thing new. And it was a pleasure to be here, and yeah, enjoy your conference.